Hello guys, welcome to Digital SAT Math Test Prep video presented to you by SX Math Help LLC. We are the math tutors in Montclair, New Jersey. Our contact information is listed here in case if you have any questions. Please feel free to reach out to us. And today's topic is linear equations in one variable. Linear equations in one variable. This is an algebra topic. All right, so that's what we will be talking about today. So let's take a deep dive. All right, so the first question asks you to find the value of x in the below equation 5x plus 10 is equal to 30. So let's do this. 5x plus 10 is equal to 30. So clearly we need to isolate x. In order for us to isolate x, let's first remove 10 from both sides. We have positive 10. The inverse of the positive 10 is negative 10. So if you do something on the left side, you have to do the same operation on the right side to keep the equation in balance. So 10 and negative 10 gets cancelled out. So you're left with 5 times x on the left side is equal to 30 minus 10, which is 20 on the right side. And again, we have to separate 5 and x here. So in order for us to do that, let's divide both sides by 5. And 5 and negative 5 over 5 is 1 on the left side. 1 times x is x. We are left with x on the left side is equal to 20 over 5. 20 over 5 on the right side, which is 4. So x is 4 is the answer for this question. All right. Okay, so let's move on to the second problem. So something I forgot to tell you. Always before I start working out the solutions to the problem in each page, I encourage you to pause the video and then do it by yourself, and you can always come back and check to see whether your answer matches with mine. All right, so this question is asking us to solve for x in the equation 3x minus 9 is equal to 21. So let's pretty much follow the same steps as we did in problem 1. So we have to isolate x from 3 and 9, negative 9. Let's do that. So the inverse of negative 9 is positive 9. So if I add positive 9 on the left side, I have to do the same thing on the right side. So right now negative 9 and positive 9 gets cancelled out on the left side. So I'm left with 3 times x, or 3x on the left side is equal to 21 plus 9. So I'm left with 30 on the right side. Again, I have 3 times x, but I've been asked to solve for x. So let's separate 3 out. So let's divide both sides by 3. 3 over 3 is 1. 1 times x is x on the left side. And on the right side, you're left with 30 over 3, which is 10. So this is the answer for this problem. All right. So let's move on to the next problem here. Let's see what the question is asking us to find. Find the value of x in the below equation. X over 2 minus 10 is 50. So let's read the problem here. X over 2 minus 10 is 50. Okay, again we have to isolate x here, so which means we have to move negative 10 and 2 from the left side. All right, let's do that. Let's remove negative 10 first from the left side, which means the inverse of negative 10 is positive 10. So I'm adding positive 10 on the left side. If I do something on the left side to keep the equation in balance, I have to do the same operation on the right side, which is adding plus 10. So negative 10 and positive 10 get cancelled out. We are left with x over 2 on the left side is equal to, on the right side we are left with 50 plus 10. So we are left with 60 on the left side, on the right side. All right, so now the question is asking us to find x. So let's multiply both sides by 2. So this 2 and 2 divided by 2 is 1. 1 times x is x on the left side is equal to 60 times 2, which is 120. So this is the answer for this problem. All right. Again, pause this video, try to solve this problem by yourself, and then you come back. Okay, let's do this problem. Solve for x in the below equation. This question is slightly different from the previous 3 questions that we did, right? Because the x terms are scattered here. You see, you have 4x here, you have negative x here, you have x here, and you have the numbers scattered too. Negative 8, 10, 52. So let's take care of this. So first of all, if you see problems like this, you have to consolidate or group the like terms. Here the like terms are 4x and 4x and negative x on the left side, and the other set of like terms or constants are negative 8 and 10. So let's group them together first. If you see the like terms being distributed on one side, first consolidate them or group them. Okay, let's do that. So we have 4x minus x, which is 3x on the left side, negative 8 plus 10, which is positive 2 on the left side. So we have fully consolidated the terms and then combined them into two terms. One is an x term, one is a constant term. On the right side we have 52 plus x. Okay, so now the question is asking us to solve for x. So let's get rid of this positive 2. So which means the inverse of positive 2 is negative 2. Let's do the same operation on the right side as well to keep the equation in balance. 2 and negative 2 on the left side gets cancelled out. You are left with 3 times x, or 3x on the left side, is equal to 52 minus 2, which is 50, and I'm also left with this x, positive x, 50 plus x. That is what you have on the right side. And again, as you see here, there's a mix and match here. 50, the constant term and the variable term both are present on the right side. Let's get rid of x from the right side. If I do something on the right, I should do the same operation on the left. So x and negative x gets cancelled out on the right side. On the right side I'm left with 50, and on the left side I'm left with 3x minus x, which is 2x, 2 times x. And the question is asking us to find x, so which means divide both sides by 2. 2 over 2 gets cancelled on the left side. We are left with x is equal to 50 over 2, which is 25. That's the answer for this problem. All right. Okay, so let's move on to the next problem. So okay, pay attention to this problem. This problem is slightly different from the other 4 problems that we just solved. This problem is asking us to find the value of x plus 2. Pay attention to that, x plus 2, not x. All along we've been solving for x. So in the SAT test you must read the question very carefully, right? There may be subtle nuances to the question, or tricks or twists to the question. So you must read each question very carefully, each word or each phrase in the question very carefully. Okay, let's solve this problem. So the question is half times of x minus 8 is 34. So if you see a problem like this where you have to deal with fractions, just get rid of the fractions. Just make sure that you don't have anything in the denominator. That will be easy to do. Once you reach that point, it will be very easy to solve the problem. So here the fraction I have is 1/2. So I don't like this fraction, so I want to get rid of this fraction, so I will multiply both sides by 2. Alright, so in this case now what you're left with is 2 times 1 over 2. 2 over 2 is 1. This gets cancelled out. I'm just left with x minus 8 on the left side, and on the right side I have 34 times 2, which is 68. You see how clean the equation has become now once you get rid of the fractions. So if we have 1/3 times something is equal to something, just multiply both sides by 3. That's the trick I want you to follow. So by this way, this fraction gets 3 divided by 3 gets out, and you will no longer have to deal with the fractions. All right, so that's something I want you to remember. Fractions multiply by its inverse. Now, so x minus 8 is 68. Again, we are asked to find x plus 2. So let's find x and then find x plus 2 in this problem, right? So let's add the inverse of negative 8, which is positive 8 on both sides. So we are left with 8 and negative 8 gets cancelled out. We are left with x on the left side. 68 and 8 is 76. And again, pay attention here. The question is asking us to find x plus 2, not x. So you should not stop here. So you should continue to find x plus 2, x plus 2, which is 76 is x plus 2, which is 78. So x plus 2 is 78. That's the answer to this problem. Alright, always read the question please very carefully. Okay, the next problem is asking us to find the value of x. So it's a very straightforward problem, except that there are fractions involved in this problem as well. So let's start with this. Half times of x minus 4 is 1/3 times of 3x minus 9. And again, pause this video and solve this by yourself first, and you can come back. So again, I have two different fractions here. I have 1/2, I have 1/3, and the least common multiple for 2 and 3 is 6. So I'm going to multiply both sides with 6 to get rid of the fractions 1/2 and 1/3. So I'm going to multiply both sides with 6. Alright, so I have 6 times of 1/2 times of x minus 4 is 6 times of 3x minus 9. So I just took this equation and I'm multiplying both. Excuse me, I missed this 1/3. Let's do this again. I'm sorry. 6 times on the right side, I'm left with 1/3 of 3x minus 9. Okay, let me make sure I got every term from here. So the only difference between this equation and this equation is I have multiplied both sides by 6, which is the least common multiple for both 2 and 3. Okay, so now 6 over 2 on the left side, I am left with 6 divided by 2, which is 3 times of x minus 4 is equal to, on the right side I am left with 6 divided by 3, which is 2 times of 3x minus 9. Okay, and again, so now we have to use the distributive property. The distributive property, as a reminder, says a times of b plus c is a times b plus a times c. A times of b minus c is a times b minus a times c. So that's what distributive property rule is all about in algebra. So let's do that. So let's multiply the term outside, which is 3, with each term inside. Okay, so let's do this. 3 times x is 3x minus 3 times 4 is 12. Let's do the same thing on the right side. So let's take this 2 and multiply with each term inside. So we left it 2 times 3x, which is 6x, minus 2 times 9 is 18. And again, now we have numbers and letters or the variables scattered on both sides. We have to eventually solve for x. So let's remove 12 from both sides. Let's remove the 12 from the left side, which means we have to add 12 on the left side, and I'm doing the same operation on the right side. This gets cancelled out. I am left with 3x is equal to 6x. Negative 18 plus 12 is negative 6. Okay, so let me do the same thing here now. Let's okay, so the number, let's remove 3x from both sides. This becomes 0 is equal to 3x minus 6. Let's do one more step by adding 6 on both sides, and we are left with 6 equal to 3x, or 3x is 6. We have been asked to find x, which means we have to divide both sides by 3. 3 over 3 is 1, so we are left with x is 2. This is the answer to this problem. Alright, okay, let's move on to the next problem. Solve for x in the equation. 0.5 times of x minus 20 is 0.4 times of x minus 40. Alright, so let's rewrite this problem in a different way, because again, I don't like decimals in the problem. I don't like fractions. In the previous problem, where you encounter a fraction, you multiply both sides with 6 because that's the least common multiple for 2 and 3. In this problem, you multiply both sides with 2 because there was a 2 sitting here on the left side in the denominator. So here there's a fraction that's sitting on both sides of the equation, right? And I don't like fractions. I would like to deal with whole numbers, or integers rather. So see what I'm doing. So I'm going to take the 0.5 times x minus 20 is 0.4 times of x minus 40. To get rid of the decimals, I'm going to multiply both sides with 10. Alright, so it becomes 10 times 0.5 times of x minus 20 is equal to 10 times 0.4 times of x minus 40. Alright, I'm just multiplying both sides with 10. So now 10 times of 0.5, or 10 times of 5/10 is 5. And we are left with 5 times of x minus 20 is equal to 10 times of 0.4, or 10 times of 4/10 is 4. And we are still left with x minus 40. Now, as I noted in the previous page, let's use distributive property rule here again, where we take 5 to each term inside, multiply 5 with each term inside the parenthesis. So we are left with 5 times x is 5x minus 5 times 20 is 100 is equal to 4 times x is 4x minus 4 times 40 is 160. Alright. So now let's get rid of this 4x from the right side. So I have to do negative 4x, which is the inverse of 4x. This gets cancelled out. On the right side I am left at negative 160. On the right side I am left at 5x minus 4x, which is x minus 100. To get rid of this negative 100, let's add 100 to both sides. This gets cancelled, 100 and negative 100 gets cancelled out. I am left with x on the left side, which is what I want, and on the right side I am left with negative 160 plus 100, which is negative 60. That's the answer for this problem. Alright. Again, as you see here, I got rid of the decimals by multiplying throughout by 10. So 0.5 became 5 and 0.4 became 4. And also I used distributive property here. A times of b plus c is a times b plus a times c, or a times of b minus c is a times b minus a times c. Okay, so both there are two functions or operations that I have done to solve this problem. Alright, let's move on to the next problem here. Okay, pay attention to this question please again. The question is not asking you to find x but 2x. Alright, so now find the value of 2x in the below equation. Again, pause this video and then try to solve this problem by yourself. Okay, let's take this equation. We have 2 times, we are given 2 times of 3x minus 9 is 3 times 3x minus 9. And again, we have to use the distributive property rule. As a reminder, distributive property says a times of b plus c is a times b plus a times c. A times of b minus c is a times b minus a times c. That's a distributive property rule in algebra. So let's take this 2 and multiply with each term inside. Let's take this 3 and multiply with each term inside the parenthesis. Alright. So now on the left side we have 2 times 3x, which is 6x, minus 2 times 9 is 18. And on the is equal to, on the right side I am left with 3 times 3x, which is 9x, minus 3 times 9 is 27. Okay, now numbers and letters are all mixed up on both sides. Let's try to get rid of this 18 first on the left side. So the inverse of negative 18 is positive 18. I'm adding positive 18 on the left side, which means I have to do the same operation on the right side to keep the equation balanced. Negative 18 and positive 18 gets cancelled out. I'm left with 6x on the left side is equal to 9x. Negative 27 plus 18 is negative 9. Alright. Okay, now let's remove 9x from the right side. I have to do the same operation on the left side. So these gets cancelled out, 9x and negative 9x gets cancelled out. On the left side I am left with 6x minus 9x, which is negative 3x, is equal to, on the right side I am left with negative 9. Alright. So now we have been asked to find 2x. So let's find x and then find 2x. Always keep your question in mind. So first let's divide both sides by negative 3 to get rid of negative 3 sticking with x here. So we are left with x is equal to negative 9 over negative 3, which is 3. Now the question is not asking you to find x but 2x. So it's 2x is 2 times 3 is 6. That's the answer for this problem. Alright. Okay, so let's move on to the next problem. So I have added a couple of word problems here. So some word problems appear in context in the SAT math test. So let's try to solve these problems, right? Okay, now I go to a store and buy 5 umbrellas that cost $8 each. I'm left with $10. How many dollars did I have before I entered the store? That's a question. Okay, so I buy 5 umbrellas which cost $8 each. So I spent $40 to buy those 5 umbrellas. This is a cost of 5 umbrellas. Is 5 times 8 is 5 times 8, $8 per umbrella. So I spent $40 for the umbrella and I'm still left with $10 in my pocket. So essentially before I enter the store I should have had $50. Okay, so this is kind of linear equation one variable problem. The variable is the number of umbrellas you buy here or the cost of each umbrella, and then you solve that. Okay, so let's move on to the next problem. Okay, this problem states that 10 less than half of my current age is 15. So what is my current age? That's a question. So let's try to convert these phrases or words or sentences into mathematical form. Okay, 10 less than, that means you have to remove 10 from something. Half of my current age, if I assume my current age is C, half of my current age is C over 2, or half C, is the mathematical equivalent of the word is equal to, and I have 15. This is what it is. And what is my age? What is my current age? The question should be, what is my current age? In our case, it's a letter C. That's a variable that we assumed as a current age. See how I converted. Let me repeat this one more time. 10 less than, that means minus 10. Half of my current age. If my current age is C, if my current age is C is a current age. C is the current age. If my current age is C, half of the current age is C over 2. So C over 2 minus 10, the word is means equal to, is 15. That means it's equal to 15. Now it's a matter of just solving for C. Let's do that. We have negative 10 on the left side, add 10 to both sides to get rid of the 10 on the left side, and we are left with C over 2 is equal to, on the right side we have 15 plus 10, which is 25. And again multiply both sides with 2, because we have to essentially find the value of C. These gets cancelled. So C is equal to 25 times 250. So I am 50 years old. That's my current age. Okay. I hope you got this problem. And there's one more. I think this is the last problem we have for today. And let's see what this is all about. 3 less than 4 times the number is 6 more than 3 times the number. What is the number? Okay. We have to convert these sentences into mathematical equations. Let's do that. 3 less than, that means some 3 should be removed from something. 4 times a number. Let's assume the number is, let's assume the number is x, the variable x. So 3 less than, so we have got minus 3. 4 times the number, 4 times of x, which is 4x, is the mathematical equivalent for is, the word is equal to 6 more than, that means it's plus 6, 6 is added to something. 3 times that number, the number is x, 3 times the number is 3x. That's it, we formed the equation. Now it's a matter of just solving for x. So let's do this one more time. 3 less than, that's minus 3, 4 times the number, that's 4x, is which is equal to 6 more than 3 times the number, that is 3x plus 6. Okay, now let's solve for x. Let's add 3 on both sides to get rid of 3 on the left side. This is gone, we are left with 4x on the left side, and on the right side we are left with 3x plus 6 plus 3, which is 3x plus 9. Again, let's bring x to one side. So let's get rid of this 3x on the right side by doing its inverse, which is negative 3x. And if I do something on the right side, I have to do the same thing on the left side to keep the equation in balance. So this gets out of our way. 4x minus 3x is x, and on the right side we are left with 9. So that number should be 9. You can quickly check this. 3 less than 4 times the number. 4 times 9 minus 3 is 6 more than 3 times the number. Let's check this quickly. 9 4s are 36 minus 3 is 33 on the left side. 9 3s are 27 plus 6 is also 33. So the x is 9. X is, the number is 9. All right. So we essentially covered today the linear equation in one variable, where the variable can be x, y, m, n, p, whatever it is. We use primarily x as a variable here today, and we solved for the value of x. Sometimes a question may ask you to find 2x, 3x, x plus 5, x minus 2, whatever it is. You must read the question very carefully. And we also solved a couple of word problems involving linear equations in one variable. So when I say linear equation in one variable, the linear equation, a graph of that would be a line. I just want you to be aware, it may be a line like this, it may be a line like this. All right. So linear equation, it's an equation that leads you to the graph of a line. That's what I mean by linear equation. When I say one variable, I just have a variable like this. One variable like 5x plus 10 is 20. I don't have something like 5x plus 3y is equal to 15. This would be linear equation in two variables. This would be linear equation in one variable, 3x, 5x plus 10 is 20. All right, so we'll be talking about linear equations in two variables in the next one of the upcoming lectures. But that's all for today, folks. Thank you for your time. I hope you really got something out of this lecture. Keep practicing. If you feel you're not comfortable with, or if you need more practice, go back and redo all the questions in this posted in this video, and I'm sure you will get a great score in the SAT test. Okay, good luck.